Hey guys, at home I'm having my first hour here to run a little test. If more than half of them get this right, I'm going to skip part of the notes because part of today's section we've done already. So you might want to try it at home too. But I think it'll be fine. I'm not sure though because we haven't done a ton of them. But I did talk about this ahead of time. Whoops. All right, oh, limit. And let's do x approaches 2. So I'm giving them, you might want to pause the recording. I'm giving them some time. I'm just going to walk around, see what they get. And then we'll go from there. We might be skipping a couple pages of the notes. If more than half get it right, the other half should ask me during the work time, but I'm not going to make everyone listen. Does that make sense? It kind of gives you more homework time this way. So if Quinn's like, I already know how to do this, I don't want to listen to it for 10 more minutes. You won't have to, but we'll take care of it at the end for those of you who don't have it right. So when you're done, if you guys in here, and I won't call you out if it's wrong. I'll just walk around tally in my head. When you're done, circle your answer and put your pencil down so I know to go check you guys. There's not very many in here. And so while they're doing that, there's a test coming up. We're going to be testing on Tuesday and Wednesday of next week. So tomorrow is a review. It'll be posted. And then also tomorrow, I'm going to run a Google Meet from 1:30 to 2. So where I kind of talk about test specifics. In order for you guys to be able to fix your test, I don't do test retakes. It's just not possible really. But what I do allow first semester is what I call test redemption, where I will give you a certain percentage back based on stuff you need to do. The first thing though to be eligible for that is you must have had all your homework in. So if your homework's missing by the day of that test, that won't happen. And if you don't show up for the test review, I'm going to assume it's because you didn't need it. If you need it, you should show up and not bank on a retake. Don't you guys agree? All right, but if you've done all your homework, you go to the test review and you're like, get an 85, and you're like, I know I could do better. I do allow you to redeem some percents back, but I don't make you do the stuff you got right over again. So I don't give you a big packet. I just sort of, does that make sense? So there's 2 things to be eligible for that, and that's why I'm recording it today. One is you need to have all your homework in. All right, and in Schoology, I enter on Fridays for the previous week, and I put what you're missing in there. The other one is you have to show up to the test review on Friday. What time? 1:30 to 2 o'clock. Now, my first hour kids, that's during 6 hours. So if you can't make that time because maybe you have a biology test or something 6 hours, just email me and I'll do telling me you're interested, and I will do a special one for you guys probably on Monday sometime. Okay? Maybe Monday evening or something, or I'll figure it out. But if I don't get an email and or you don't show up on Friday, I'm going to assume you don't need the review, which a lot of you don't. That's why I'm not going to do does that make sense? It's extra review to what we're doing on Friday. All right, so I'm going to walk around here. If you guys have your answer circle, where's yours? Do you have your answer circle there, Sparky? Move your hand. Where's your answer? All right, most of you got it right. The answer was D and E. One person put undefined. I take it. I prefer D and E. The limit here does not exist. So I will come back to this one at the end of the hour because most got it right. I think 2 have it wrong. So I'm going to come back. Those of you at home, this will be one that I'll discuss in that test review as well, just not to leave you hanging. All right, so the notes, we're going to that's what the first part of the notes are about. Well, what if you hit an asymptote when you're doing the limit, right? And you're either going to infinity or negative infinity. One of you put positive infinity, you were close. A D and E. Why was it D and E?
Because they were going up.
Yeah, from the right it went up to infinity, right? And then from the left of 2 it went to negative infinity. So that was a D and E. We are going to go in the notes to the page that looks like, I think we'll go right here. All right. This piggybacks off of a pre-calculus topic, so, and then we just make it a little bit more difficult. So we're going to be taking, so far, by the way, you've been taking limits as x approaches a constant or a number. And we have an algorithm for that. You plug it in. If you get an answer, that's your answer, right, Elena? If you get 0 over 0, we've got problems. There's a hole in the graph somewhere, but there's a limit there, right? And we have various ways of finding it. We factor cancel, or do the conjugates, right? Or clean up a complex fraction, or maybe it's tricky, but we deal with the issue that's causing the 0 over 0. Or like that last one, we get a number over 0, right? And when you get 0 on the bottom and it doesn't cancel, you hit an asymptote. And you can only do one of 3 things. Up to infinity, down to negative infinity, right? Or if it's a two-sided limit, like that last one was, and like Quinn said, because it's up on one side, down on the other, we put D and E. All right, so that's kind of what we've been covering in here as far as the limits go. Now we're going to be approaching infinity. And we're going to see what happens. I don't even want to read this to you about pre-calculus. We'll go back to it. All right? In pre-calculus, these were given. This is starred. What does it mean when I star? Yeah. And I'll be even more transparent about it. That's what I'm going to do on Friday in the Google Meet. Is I'm going to say, let's take out your notes and a highlighter, and I'm going to show you. I don't give you a big review packet. Some people don't need it. If you're like, I got it, right, Quinn? And I've got AP Physics backed up. Work on that. Why study for a test you got? But if you don't, you better study for it. All right, so here we go. As you approach infinity, take a look at this. What does your gut tell you it does? Maybe you remember pre-calculus. What do you think happens as you approach infinity on this function right here? Anyone have a gut reaction? It does approach 0, and you can see it on the graph. What do you think happened here at -2, where there's this hole right here? What do you think happened analytically or algebraically? Removable, factored, and it canceled out, right? But you'll notice that this, as I go to infinity on the x-axis, this is bound by 2, or by y equals, is that 2? Where's the, I'm having a hard time reading my grid. 0, I'm sorry. It's bound by 0, so I couldn't find the origin. So that y equals 0 is called a horizontal asymptote, right? Were you taught in pre-calculus that if the bigger power's on the bottom, it goes to 0? That's true. Bigger on bottom goes to 0. Bobo. Okay? That is totally true. And if it's multiple choice, for God's sakes, I want you to say, this is going to 0. The bottom's killing it. It's small over big, right? Think of 2 over a million. Because remember, infinity is huge, right? Think of a million over infinity. It's still going to be 0. A trillion over infinity, what's it going to be? 0, okay? Because infinity is so big, it takes over everything. So higher power on bottom, we will go to 0. And this will imply that y equals 0 is a horizontal asymptote. So we've got the limit being 0, and you have to make sure you also understand that that provides a horizontal asymptote on the graph. However, I do kind of want to show you at least just with one of them, because I actually think I'm going to stick pretty much with that method of just intuitively knowing what's happening, like Quinn said at 0. But this is really what's happening to make it 0. Okay, I'll show you just once. If you were taking this in college, by the way, if you're listening to this and you hear my breathing, I'm behind a shield and it's hard to breathe. All right. Anyway, so if you were in college, there's a more analytical way than saying, hey, Bobo, bigger on bottom, 0. It goes like this. They tell you to take the largest power in the denominator, which right here is x squared, okay, and multiply or divide every single term by x squared. You might say, how is that legal? Multiplying by 1 over x squared is the same as dividing by x squared. And what did I just write here? What number is this no matter what? 1 over x squared over 1 over x squared. What is it? 1. So it's perfectly legal for me to divide every term. It's kind of like distributing this 1 over x squared. And watch what happens. We would get 6 over x squared. And we would get, you might say, why is she writing that like that? This would be 5x over x squared, which is just 5 over x, correct? And this would be x squared over x squared, which is 1. Okay? Now watch. On the top, it would be 2 over x squared and x over x squared. Now watch. As x goes to infinity, this goes to 0. Any constant over x, so that's going to 0. 5 over a gazillion is going to 0. This is going to 0. This is going to 0. The top is 0. The bottom's 1. I analytically get 0. That's the collegiate way to do it. Do I want you doing it that way? I don't. I want to expose you to it, but I want to tell you that intuition's awesome. But watch this. In pre-calc, you were told that if the powers are tied, what do you do? What do you do if the powers are tied? Do you remember, Caden? You do. You use the coefficients of the lead powers. These guys are in control. The bigger ones on the top and the bottom, they are tied. So this is going to be 2. And that's a great way to reason it. And I want you to do that. But I do want to show you one more time the collegiate way. Like if you had a college professor, they're going to go, you got to show me how to do that. By the way, what does that mean is a horizontal asymptote of this function? Y equals 2. Now one more time. If you were in college, this will be the last one I do that way. What would you have to divide everything through by? X squared. 6 over x squared will go to 0. 7x over x squared is 7 over x. 2x squared over x squared is 2. Right? This will go to 0. This will go to 0. This will go to x squared over x squared. You see the 2. And you'd have to write it all out. And it depends on how picky your professor is. I'm going to tell you with these, I'm not picky. I'm normally going to be probably the pickiest teacher you ever had. Like when I grade your tests, it's like I am tearing that sucker apart, right? But I do allow you to fix it if you deserve that. So, but I'm not picky on these because I think it makes them harder. So what were you told in pre-calculus about if the higher power is on the top? So it's bigger on bottom is 0, Bobo. Bigger on top is undefined. Bobo Batu is our friend. We'll remember him. Maybe we should drop each other. You ready? Here's Bobo. He's got a big 0 head. And Batu, you can't see because he goes to infinity. So there's Bobo, there's Batu. Aren't they cute? But Batu's going forever. And actually his legs are going way down too. You just don't know. This is the problem with the undefined. You have to decide which one it's going to. Now take a look over here. You might say, what does she mean? Go over here. As I go to infinity, do you see how this graph, I do always like you to see the graphs. Do you see that red arrow is going up forever on the graph? We'd say it's unbound or there's no horizontal asymptote. So as I am approaching infinity, you can see on the graph that this is infinity. But Kaden, I'm going to take the graph away. So then for you to decide, you're going to go and do this. U plus 2 in the grand scheme of infinity does nothing. On the top, this doesn't have any control on the top. This doesn't have any control on the bottom. You go look at the biggest things on the top and on the bottom. If the top is bigger, Nick, we go to one of the infinities. To decide which one, you do sign analysis. Put a positive in here, right? Square it, you're still positive. The bottom's going to be positive no matter what. You might say, yeah, but you're subtracting 1. Yeah, from infinity, it's still positive, right? So that's how you analytically decide that that's going to infinity. So watch me change it, a little negative infinity there. I still would say, you're in control, you're in control. But now when I do negative infinity squared on the top, right? So when I do, let me grab this. Give me 1 sec. I'm going to grab a highlighter. So now when I do negative infinity squared, I'll have a positive on the top, right? And then a negative infinity. Again, I said, if you missed what I said, what if this was negative infinity? So then you would say, okay, it's unbound. It's going to one of the infinities. Do a sign analysis, and you can see on the graph it's going to negative infinity. Does that make sense, Keaton? So we're going to make these. That's why I did delta math today. You aren't going to have to show hardly any work. You're going to be thinking them through. You're going to be really careful though, because I put a high penalty on it. So like if Lainey, perfect. So if Lainey goes to delta math, I only assigned 3, but I put a 1 problem penalty in it. And there's really not much work to do. She's going to say, oh, 0, 2, infinity, right. She can move on to this one. So if you can see it, you'll be really good. If you get a red X right here, make sure you read what delta tells you, because that's what's going to slow you up. So it's very self-paced today. If you get it, you're going to cruise. All right, I do delta math when it's something like that. So on this one, it says now let's see what happens. Oh, I just did this one. I just changed the positive infinity to a negative infinity. This guy, I just talked about that. You're my first class, so I didn't anticipate. I haven't done this since last year. I just talked off the top of my head. I like that once. Kind of weird, right? All right, let's go back up here. So I want you to take a look at this guy. Now, you go to the highest powers. Boom, boom. Right? The highest powers are tied. We steal the coefficients. Now notice, it still was a positive 2. So when we have these polynomial functions, going to infinity or negative infinity actually yields the same horizontal asymptote. What is the horizontal asymptote? Y equals. Thanks for saying y equals. Y equals 2 is the horizontal asymptote. Remember on this one though, we had to decide between positive or negative infinity. And so that one you have to be careful on. All right. So and I feel like you're getting it, so we're going to go practice. We're going to do it with an intuitive understanding of what's going on. All right? Look at that, and if it's multiple choice, and if it's delta math, which these all are in the AP exam, that's why I'm not having you show it real formally, because you won't have one of these as an FRQ. It's not worthy. It's not a big enough topic. So when you're looking at that, who do you cross off on the top? The 5, that. Don't cross the sign off while you're doing it. All the non-highest powers are not in control. They get totally beat out by the highest powers. Then you look at that and you say, they're tied. Right? So Cameron, what's your answer for this limit? Negative 2/3. And if on the AP exam you were asked to find all horizontal asymptotes, y equals negative 2/3. And remember, when we change it to positive infinity for these when they're tied, it doesn't change for the polynomial. So there is just one. But really for the horizontal asymptotes, you have to check what's happening as you go to infinity and negative infinity. Now let's go to this guy. We go like this and take off the non-controllers on the top. The non-controllers on the bottom don't nick off signs. So that yellow stuff, you don't even look at it. Okay? So then I go bigger on top. Batu. Right? Where's Batu going? Bobo's going to 0, bigger on bottom. Where's Batu going? Undefined, which means your answer is either infinity or negative infinity. You do a little sign analysis to decide. You go to the top, so we know that this is Batu, right? We know it's infinity or negative infinity. We could guess, but we don't want to do that. So then we do a sign analysis. We take a negative, we square it, and we'll have a positive on top. We take a negative, and we do a negative of it for a positive on the bottom. So if I were to graph this and head towards negative infinity, it's end behavior. I think that's what they call it in pre-calc, don't they? It's end, that's what this is end behavior. Its end behavior is that it's going to infinity. What do you think? I'm going a common sense approach to these instead of super analytic. All right, I think we're on the last page here then. Now I'm going to mess with you because now I don't know that you went this far in pre-calc. What's the difference on here? What's the difference with this one from the other ones? What do you see in there, Ryan, that we didn't see on the other ones? Yes, you got to be careful how you deal with that. Because usually when I ask kids, what's the square root of x squared? What do they tell me? What's the square root of x squared? They say x, and it's not. If you were to go to your calculator and graph under the y equals the square root of x squared, here's what your calculator would do. What does that look an awful lot like? It is. It's the absolute value of x. You might say, what? That's not what I was told. You should have been. It is the absolute value of x. For example, the square root of -3 squared is the square root of 9, which is 3. If I say, what's the square root of 25, what do you say? 5. Right? You don't say plus or minus. You might say, I was taught to do plus or minus. The only time you do plus or minus is when you're solving an equation. The square root of 9 is 3. But if x squared equals 9, what's x? Plus or minus. Kids get really sloppy with that in their preschools. Every year they come in and I say, what's the square root of x squared? They go, x. I'm like, it is if x was positive. So you have to be really careful. So when this is what I'm saying with these, we're still going to take a nice, easy approach to these. Okay? What we're going to do, by the way, it says in the past. Let's go point at that root. So let's go take a look at what happens on this guy. Let's look at the graph first, though. Here, I'll get my absolute value graph up here. You'll notice a couple of different things happening with this graph when I put that root down. First of all, to the right, I know as I go to infinity, the answer is going to be 2. I'm going to put that right there. As I approach negative infinity, something else kids don't understand. Do you see how I just crossed my horizontal asymptote? Kids always think they can't cross asymptotes. You can't cross vertical ones. But you can cross horizontal a lot of the time. Watch. If you graphed a function, if you graphed a function and it went like this, and let's say here's our horizontal asymptote, I'd still say as I go to infinity, this isn't passing the asymptote, but it did at first. But you can't do that with a vertical asymptote because then it's not a function. What test would it fail? Vertical line test. You see? It all kind of makes sense. So let's go see what we do with these. The only thing you're going to have to do is be very careful. This one still is not in control. This one still is not in control. So I'm really analyzing 2x over, but the square root of x squared is not x. What is it? Absolute value of x. And you have to decide, when you put in a negative, my answer is 2 or -2. Don't you agree? These are tied. So let's go like this. I know it's 2 or -2. I've got tied powers, first degree, first degree. And again, it's sign analysis. The absolute value when x is negative will be positive, correct? What's it going to be on the top when I put in a negative? See what I mean? So now I get to say, oh, for sure -2, and you can see it here graphically. So watch the next one. Gone, gone. The square root of x squared is the absolute value of x. Now when I do a sign analysis, positive, positive, 2. It's like a puzzle. They're kind of fun. Right? If you don't do them the long way, they're kind of fun. So, next one up. Didn't I just do these two? Or has it changed? Those are pretty much the same thing. So, here we go. I want you guys, I'll do this one, and then you guys are going to go do the other one. So here we go. Who's not in control on the top? -2. Who's not controlling anything on the bottom? +1. Okay? You're going to consider that 3x over. Be careful, because that's a √2, right? And the square root of x squared is the absolute value of x. That's how you're going to rewrite it in your head. Am I making sense, Ryan? Okay? And then to decide, you know it's plus or minus 3 over √2. So if it's multiple choice and you don't know what to do next, you guess one of those. Because the powers are tied. And when the powers are tied, we steal the coefficients. So I'm going to go like this. But you have to decide right here how this is working. On the bottom, when I put in negatives, because again, x is approaching negative infinity, the bottom will be positive. On the top, when I put in negatives, boom. So what's my answer? Negative. Now be very careful. I'm actually going to cross this one off and I'm going to change it to 1 like on delta map because they have them even a little more complicated. Suppose it's 3x squared plus 1 over the cubed root of x to the 7th plus 2x plus 9. And I'm just making this up on the top of my head, all right? You're still going to follow the exact same process, Quinn. You right here, come on. Oh, there we go. Okay, this guy, come on, hand. Oh my God. All right. Now it's still in my way. Oh my God. It doesn't matter. I'm going to cross. All right. Get out. Okay, now it's out. All right. I'm just going to go back to the pen. I'm going to cross that off because it's not in control. Not in control. Not in control. You might say, oh, it's plus or minus 3. Be careful because those exponents aren't tied. This is really x to the 7/3. Where's the power? On the top or, I mean like the most power. On the top or on the bottom? Bottom. Yeah, the highest power on the top is at 2. On the bottom, this is really 2 and 1/3, right? What do we do when there's a bigger on the bottom? Oboe. Yeah. What does that mean graphically happens? Discuss. There's one on the test where I say, find the limit and discuss the horizontal asymptotes. What would you say? The limit is 0, and therefore, right, what would you say? There is a horizontal asymptote at, yeah. Now, if you end up having your answer be infinity, right, you would say the limit is going to infinity, which means there are no horizontal asymptotes. Or you could say it's unbound, but it'd be something, you know, like a cubic function. They don't have any, right? So if you get the infinities, it just means no horizontal asymptotes. Now, I'm going to add this, because this is actually really important. And then I should be done in 5 minutes here. You know how we were talking about the powers? Like x to the 4th beating out x to the 3rd? Those are actually just one function family. Those are exponential functions. But other function families have different strengths. The weakest in the world are the constants. The constants get beat out by everything else. So if there's a 5 on the top and an x on the bottom, right? It's going to go to 0. Constants get killed. The next weakest function are the natural logs and the logarithms. They grow so slowly. Constants don't grow at all. And the natural log and log functions grow incredibly slowly. So the only thing that actually beats out constants are logs. What does she mean by that? If I said, oops, I don't want to write there. Don't write it down. I'm going to put it right here. If I say, what's the limit as x goes to infinity of 7 over the natural log of x? This is a bigger function family. Bigger on the bottom. What does it go to? 0. Okay? And if it were on the top, we'd go to one of the infinities. Does that make sense? So after the constants come the, I guess you'd call them the x to the n's, like x squared, x, the power functions, right? So x squared on the bottom will beat out both of these two. X squared over ln x going to 0. X squared over constants going to 0. Constants over x to the n. So anyway, let's go put the next one up. The next is the exponential functions. Like 2 to the x, 3 to the x, e to the x, 4 to the x, 5 to the x. We work with e to the x a lot. That's a killer. You should get y graphically, right? e to the x is exponential growth. Do you see how its y values are totally going to overpower any line, any ln function? Whoops, I left the domain. And they actually even take over any exponential function eventually. All right? So the last one I'm not going to put on there because you don't need it till Calc 2. So for you guys, the exponential functions are king. If they're in the denominator, and any of the other ones are on the top, from 1 to 0. Does that make sense? So we're going to practice this one. I took these off at Delta Math, like in the harder sections. First thing I'm going to tell you is we don't like negative exponents. What did I say, Kaden? We don't. And what do you do when you have a negative exponent? Where were you taught to send it? To the denominator. I would do a rewrite on this one. Okay? I'm going to actually just go like this so I don't have to rewrite the whole thing. And if you just want to watch these, that's okay. But I'm going to put it on the bottom. Now, these are function families, but the bigger one's on the bottom. So what do you think this limit is? The bigger one's on the bottom. Yeah, if you were to go graph this guy's it's going to be approaching the y-axis because this guy's going to kill this guy. E to the infinity is going to just kill it off. Okay? So this is 0. What does that mean about the horizontal asymptote? There is 1 at y equals 0. Is there another one? We'll discuss that down here. All right, so the next one. This is a big mess. You may say, what? When we go to infinities, it's always, think infinity big. It's always about where the biggest stuff is. If it's just powers, it's the biggest power. But if it's mixed functions, it's the biggest function. So what you do is you go take e to the x is a bigger function than this one. It's king. All right? Down here, the 23rd, those are your bigger functions. But where's your bigger function family? On the top or on the bottom? Top. It will eventually take over. So what do you know when you have a bigger on the top? Where are you going? It's undefined. And actually, Delta Math just has clicks. So you would click on D and E. But if you had to know which one it was, which of the infinities it was, would you know? Just based on sign analysis. D and E is good. Infinities don't exist. But I like you to even refine that a little bit, Elena. What infinity do you think it's going to? Based on signs. As we, oops, I thought I had my highlighter. As we approach infinity from the positive direction, so in your brain you're thinking positive, a gazillion, is going in right here and right here. Crap. And right here. Are we going to go to infinity or negative infinity? Negative. Yep, because of that sign right there. So you look at, all right, last one up. It's the hardest one. If you don't understand it, that's okay. They had one of these on the AP exam in 2008 and it got taken off because very few kids got it right. So anyway, but I always like to expose you to some of the super hard stuff. So if this says to find the horizontal asymptotes of this function. Horizontal asymptotes are limits as you approach what? Not constants, right? Limits as you approach what? That whole connection between limits and horizontal asymptotes. Okay, here's my horizontal asymptote up here at 3. And I am bound as x approaches what? Infinity. They're limits as we go to infinity. But we could have one over here too as we approach negative infinity. And they can be different. So you need to analyze both. And that's where kids screw up a lot is they only go to positive infinity. Let's do that first though. Limit x approaches positive infinity. I'm just going to call that f of x right now. Kaden, what did I say about negative exponents? I don't like them, right? So I'm going to actually make this 1 over e to the x for right now, okay? I don't like them. So let's go take a look at what happens as I go to infinity. What is this? Sorry, people at home can't see me pointing. What is that going to go to as x goes to infinity? Just the 1 over e to the x. Yep, you're right. Say it right. 0. This will go to 0. It basically has no power. It'd be 1 over a gazillion. Well, that's not doing anything. On the top, what else is not doing anything? Right. So you should immediately see one of the horizontal asymptotes is 3/5. Why 3/5? Just to make sure. What do you think, Max? Why 3/5? Why did I say that the limit is 3/5? Help them out, Cam.
Because they're the same.
Yeah, if you can't hear them at home, he's saying because they're the same powers. Those people in control are tied, and we steal the coefficients. Now this is where you have to be, and this is what a lot of kids nationwide clicked on. But watch what happens as x approaches negative infinity. So let's go back up here. And again, just watch. You don't always need to write everything in your notes. I'm just going to go over here. And I'm going to go e to the negative x. Now what happens? When I go e to the negative infinity, what would that become? Do you see that there's another horizontal asymptote that's different? Because now the figure's on the bottom. So where is it going to go? 0. Excellent. If you understood this one, it's unexpected. All right? This is kind of what I'd call it. Will I test you on this? No. On Delta Math, there's the last set, and if you're struggling, I'm okay. I'll accept 2 or 1 out of 3 or whatever. Like, you don't have to. If you don't get it, don't spend hours on it. But it's an extra challenge, and I like it. So we're done. You guys have 20-ish minutes. You should for sure be able to finish almost all of Delta Math, because you don't have to, you're just going to be looking at it. So those of you at home, only thing to do today is Delta Math, so no Google form. I'll just go in and check Delta. And if you, the very last set on the asymptotes, make sure you can get 2 out of 3, but if you're struggling on the third one when they get a little bit more like this, maybe try, and if you're getting, I can see like your red X's, and if I'm like, you know, Caden's just really struggling on this last set, don't spend an hour on it. You can bail on the last set. You have to get 3 out of 3 on the previous ones. All right? Peace out, guys. Oh, so now it activates. What's up with that? Elena, did that make sense? Good. It's intuitive, so if your intuition on these is good, the Delta Math just cruises. If not, ask for help and I'll get that intuition going.